Hello children, let me explain another topic. Upthrust is equal to the weight of the displaced liquid. We will mathematically prove that. Okay, upthrust is equal to the weight of the displaced liquid. What does it mean? When we immerse a liquid, when we immerse a body, then this body will displace some volume of the liquid. Okay, and this body will experience upthrust. And it is said that the amount of upthrust it will experience is equal to the weight of the displaced liquid by this body. Okay, that we will prove. For that we consider this vessel which contains liquid. Okay, and we have a cylindrical body like this, okay, and pressure P1 is acting on the upper face and pressure P2 is acting on the lower face. P2 is in upward direction, P1 is in downward direction, and upthrust, as we know, is equal to the P2 minus P1 into A. Okay, that is upthrust. So we have different depths H1 and S2. Okay, so this PQRS is the cylindrical body, and we want to know what is the upthrust acting on this body, and we will prove that the upthrust acting on this body is equal to the weight of the liquid displaced by this whole body, that is weight of the volume of this cylinder, because whatever is the volume of the cylinder, that is the volume of the displaced liquid, and weight of that volume would be equal to the weight of the displaced liquid. Okay, so that's very important. So at depth h1, pressure on the upper surface is P1 equals to h1 rho g. Rho is the density of the liquid, and if what is downward thrust, P1 is acting downward, therefore downward thrust would be P1 into area, and let's say A is the area of cross section of this cylinder, so P1 into A would give you this value. Okay, now we'll see for at depth S2. For depth S2, pressure acting was P2, and P2 again will be S2 rho g. Rho is the density, g is the acceleration due to gravity, simple. Again we find F2, again A is the cross section area, so F2 is P2 into A, which is S2 rho g A. So F1 and F2 we got, and difference of this F1 and F2 will be equal to upthrust. As you know, this F2 will be greater than F1. Okay, so F2 is greater than F1 because depth S2 is greater than H1. As a result, upthrust is acting as F2 minus F1, which is this value. Okay, A S2 H1 rho g. We know that area and this height difference, this area and this difference S2 minus S1 is this, would give you the volume of this cylinder, no? So A into S2 minus H1 would be equal to the volume of the body in the liquid. So therefore we got upthrust equals to V rho g. Here V is the volume of the solid immersed, rho is the density of the liquid, g is the acceleration due to gravity. Now whatever is the volume of the solid, that is equal to the volume of the displaced liquid. Therefore in place of V we can write upthrust equals to V equals to volume of the liquid displaced into density, volume of liquid displaced. In place of volume of solid submerged, we can write volume of liquid displaced into density of the liquid into acceleration due to gravity, and that is equals to volume of the liquid displaced into density would give you mass of the liquid displaced. We know that density equals to mass of volume, and from there we can write mass equals to, we know density equals to mass of volume, therefore mass equals to density into volume. So volume into density would give you mass of the liquid displaced. Okay, I am repeating again, density equals to mass of volume, and therefore mass equals to volume into density. Here volume and density is multiplied, that will give you the mass of the liquid displaced, okay, into acceleration due to gravity. So m into g would give you weight of the liquid displaced by the submerged part of the body. Hence we got upthrust is equal to the weight of the liquid displaced by the submerged part of the body.